Okay, hey guys, hey.
No.
We don't have a whole lot of time, so let's focus here. So, quick review. What does the net force of 0 tell you? Raise your hand. Avery. Okay, that's one thing that it tells you. Emma.
Constant velocity.
Like, it can be a constant velocity or always? Okay, it can be. Okay? What else could it possibly tell you?
Is 0
Yes.
Always equal. It's
We already said that.
Good night, Lauren. Hey,
Cool.
0 is a constant velocity, so it could just say constant velocity.
Literally, Alice said that.
You know what? Those days when you really want to just punch a student, do it.
Shake a baby.
Shake a baby.
Shake a baby.
Shake the baby.
Oh yeah.
I'm the mom.
Okay. Now, so we talked about when the net force is 0. So what if the net force is not 0? What is always true? There is acceleration. Okay? Or what you would say a change in velocity, because that's what acceleration is. Okay? So, this leads us to Mr. Newton's famous second law, also known as the Fermat law. Okay, does anybody know what this Greek symbol means? Summation. I'll write it in a way that you guys will probably understand it a little bit better. How about if I write it like this? Does that make a little bit more sense?
Alright, so it makes it worse.
When you do net force, you are taking the sum of your forces. They need to be in the right components, but yes. Okay? Now, we talked about this yesterday. The bigger the mass, the harder it is to accelerate the object. What was that property known as? Inertia.
Inertia is a property of matter.
Okay? So, force and acceleration are very, very much related to each other. They're proportional to each other via the avenue of mass. Right? We're done. Let's do math.
Hey, before I start the problem, can I tell a joke?
Let's Alberto and Laura.
What do you call a guy with a rubber toe?
Okay, so shh, listen. Okay? We've kind of talked about the situation where we got no net force, and we thought you guys were working on the math problem. Stop it! I said listen. Okay? So we talked about how if the net force is 0, it means quite a bit of things, correct?
Yeah.
Could mean quite a bit of things. Alright? If the net force is not 0, it only means one thing. What does it mean?
Accelerating.
That you're accelerating. If I apply a force that's not 0, you will accelerate. Okay? So, now notice, this is really important. What we're doing probably today is probably only going to be one force and trying to determine what the acceleration is. But what if I have multiple forces? For example, if I have a force this way and a force this way, and I want to know the acceleration of this, what would I have to do first? You would have to find the net force of that resultant vector before you plugged in to this equation. Does that make sense? All we're doing today is going to be basing off of one vector. Okay? And so it's literally going to be either multiply or divide. Can you do that?
I can't do it.
Except for the last problem if we have time. Okay, so looking at this, we got Laura slides a 2.2 kilogram book toward Roberto. If the net force acting on it, now notice they said net force was 1.6 newtons. What is the book's acceleration? That's a hard one. I don't know if you guys can do it.
Wait, is there like a...
F equals F.
Oh! I just realized how they came together. What? I saw you draw a triangle and I was trying to make a triangle out of those numbers and I was like,
What?
it's not going to work.
Does it need to be kilograms? It needs to be kilograms, right?
Yes, because a force, a newton, is a kilogram times a meter per second squared. And now do you see how you get that?
Yeah.
Oh, that is. That's what a unit is. This. That's what it is. So in order to do this, it needs to be in kilograms and it needs to be in meters per second squared. If it's not, you got to get it to that. Okay? It's very possible that in your homework they'll give you a mass in grams. It is very possible.
That's
Not
dumb.
conversion. There's not one.
Avery?
Already know.
Oh, because you did it. That doesn't mean you read it correctly.
I was gonna.
Oh.
Alright.
It wasn't savage. I just said it's possible. He's a sinner. He can make mistakes. Oh. I'm a sinner. I'll make mistakes. I mean, I throw inappropriate things on the board on accident.
Imagine if a kid tries to like refuse his blessing with his parents one night and they're like.
I'm pretty sure I put it online. I'm pretty sure some of you showed your parents.
I'm waiting. I'm waiting for that. They don't hear those. They're not this one.
Yeah, that's what should.
Okay, so
You started drawing.
Yeah, that's true.
We have
Just you.
11 minutes. Perfect. Okay, here we go. So real hard. Solve for acceleration. Force divided by mass. Done.
Yes. 7.72 meters per second squared.
0.73. You
Oh,
got
Yeah,
that wrong.
it's 0.7.
Boy. Am I going too fast? Or are you guys seeing how to?
It's done.
You would have gotten that wrong.
What is your final answer? Somebody give me the final answer.
0.73
No.
meters per second squared.
No.
Kilograms.
Negative
7.2 times 10 to the negative first code.
0.73 meters per second squared to the right.
Oh my goodness.
The label's
Oh,
longer than the
goodness.
number.
Oh wait, so couldn't 0.73 be correct because it's a positive number indicating that you're going
It could be north,
Oh.
That is
Oh.
which that could still be to the right.
Wait, so, okay.
Wait, so meters.
But I could be going to the right and be going north, but I could be going to the right and be going east. Yeah.
Alright.
That's
Any number right.
0.73 meters per second squared to the right.
All right, here we go. We got a space shuttle in outer space, where space is
Where's
just gravity.
It's in gravity.
It is, dude. It's not just gravity, but there's.
No,
There's
space is
gravity.
galactic.
I'm just giving you a hard time, Cheyenne. I loved it.
No, darkness.
So
Light,
there
right.
has to be a lot of gravity.
What?
Planets would collide.
Too much gravity.
It's not a lot, it's a lack of
Maybe in the outer space where there's all that gravity, there's some aliens that have neutrons for neurons in their brain.
It's a neutron.
It's strong to be neutral, it doesn't make
Ah.
can't have
All the stars weren't
Wait, how many?
equal. You get for a
Negative
neutron. What are you doing?
I'm listening to Kramer.
Are you guys done with this next one?
Gravity is right.
Never mind, I'm not listening to Kramer.
What is the
Do the math. Do it. I don't think you'll have any
You
issues
have to
with
find
it.
direction.
It says experience during acceleration of this magnitude, so that would be assuming no direction.
To the up. Speaking of which, that's a sad movie.
Wait, what?
It's so good, but it's like kind of
Up.
You could. There's one thing in the airboat thing I was like awesome.
Isaac, are you done?
Yeah.
What'd you get?
265.
No. 2.6. Oh.
Oh, I'm sorry.
Sig big.
2.6 to the up.
Where's the
2.6
direction?
Upward, you
Well,
idiot.
it says
to
the
the
acceleration of
To
magnitude,
the above.
so you don't need a direction in this context because
Oh, okay, never mind.
since it just says magnitude, but you could still
But
put
it's
that.
up.
Yeah.
Wait, Kramer, why is the top one assume no direction? What, this one?
Because it says magnitude. It just specifically says based on the acceleration's magnitude. If you don't have a direction on acceleration, you wouldn't be able to know the direction.
Yes. Oh, you find acceleration.
What's the next one?
What? They give you mass?
You just find acceleration by dividing meters per
Did you
second.
change the units? Did you change the
units?
units? Did you change the units?
For the next one?
For this one.
How about you just know what the
You're solving for
default?
acceleration.
It's
It is
supposed to be
meters.
meters.
Oh,
What? Meters per
Yeah.
second squared. Kilograms and meters per second squared.
But did you change the units?
So you
would I do negative?
I'm so mad at myself.
I'm a little bit angry. Kramer,
Why'd
what's
you
the
give us
second
these
one?
things?
To trick you, 'cause you gotta understand the context of the problem, and just because numbers are thrown at you doesn't mean you take them and you put them into an equation and voila.
No.
Wait, so for the second one, could you use 62 newtons?
That'd give me even
Two to
more.
down. Can't you say 62 newtons down?
No, it's
You
to
could,
the
but
best.
it's to the down.
It's to the down. And
What
to
would
the
you
up.
label it?
So it's fine if it's positive. If you put
Force
negative,
is down.
wait a second.
Wait,
Could another way of rewriting like this 2,600 newtons to the up? If you wrote it, could you write it negative 2,600 newtons to the down?
Kramer, are you
So
doing
wait,
the last
Kramer,
one?
this
The very last one? Yeah, I'll do the very, very last.
Kramer for this one?
Because then the negatives would cancel out.
for this?
Oh,
we have to respect
I'm just still writing it.
No,
So
just the ones you use.
It's middle of 10.
Yes, Cole, how do you know your prefixes?
Okay, are you guys, I would wait on the very last one. That one's actually, you have to do some one-dimensional motion stuff before you can do the net force. Yes.
the third one, is it, do we keep it negative?
Yeah.
What do you
Yeah.
label the 752 millimeter long incline? Like, what does that change in X?
Which one?
The last one that you just said not to do, but what would you label
What would I label net force?
that? The incline. Like, what would it be called? Like, change in X or what?
No, so it wants for the force, it's just saying the force on the, along the incline.
So what is the incline? Like, I have.
It doesn't tell us the angle of the incline, it does. So, what I would do is I would say this many newtons of force down the incline. It doesn't give us how many
Oh, yeah. Hey, I was watching
Negative 9. Change it to equals 0.75, force equals whatever, and then.
Yeah, you're-
I didn't know that
That's
until
the last one.
75.
Yeah, I just wrote.
I was
I was like, Gina, something I know.
So
I just way out of it.
752 millimeters is 27.
Okay, can I go over this last problem here? It's the 5 kilogram book, right? Everyone, stop and listen. Stop what you're doing.
What do you want?
Okay? Did you guys get 83 newtons down for the one that was in free fall?
Yeah.
Why would they do that?
I got straight down.
I would always base it back, but I would always explain your direction versus putting a sign.
But
Yes.
you did put a sign, like I did. I put negative 83 newtons downward.
Then that would be saying 83 newtons up, yes.
So that's.
Wait.
So get rid of
why
that.
do you
No, don't
think
get rid of
it's
that.
not
What did you do?
8.5 times 1.5.
Why did you do it times 1.5? It's net force, the mass times the time.
9.81.
Yeah, it's
Wait, where is
It's
it?
in free fall. Acceleration is negative 9.81.
To make you think critically and not just take
No,
numbers
like,
and plug
where
them
does
in.
that, because I put 8.5 times and then 11 divided by 1.5 in parentheses.
Don't do that.
That would be meters per second.
You don't need the.
What's the context?
I see, it's meters per second, so you divide 11 by 1.5. No, that's what I
No.
used.
No, that's just a meter per second. That's
Wait,
just a
free
velocity.
fall.
Listen to me. Read the context of the problem. A bowling ball initially at rest is dropped from the top of a building. What's the context of the problem?
Down.
free fall.
Free fall. What do we know about acceleration always in free fall?
Negative
9.81.
8.5 times negative 9.81 gives you 83 newtons down.
How do you get?
That other information is not pertinent to the problem.
But can you get the right acceleration from it?
Maybe.
11 and 1.5 would you get?
I have to look at the equation. It would be a one-dimensional equation. Might be useful, but why would you even consider doing that? Okay? Does that make sense, you two? Why, the context of the problem? Okay, I want to get away from, ooh, here's the numbers on the problem, I have to use them. No. You don't have to use them, okay? Let's do this last one. It says, a 5.0 kilogram book starts at rest at the top of a table, inclined a certain amount. So we just got an incline. It's really not that important. The book starts at the top of the table. Okay? It slides to the bottom in a certain amount of time. So we know the mass. Okay? We know technically in this context, I know that this doesn't appear to be two-dimensional, but it's just sliding down the incline. So couldn't we treat it like a one-dimensional problem?
Yes.
And make our y-axis this and our x-axis this?
Yup.
So to answer your question, Autumn, technically we would call that a change in x. Okay, so 0.752. Why did I do 0.752?
Meters.
Because I need it in meters. We know the change in time. We don't know the net force. Isn't that what we want in this problem?
Correct.
But we also don't know the acceleration, which is what we need to find the net force, correct?
Yeah.
So we would need to find the acceleration so that we can find the net force. And since this is not in free fall, we cannot use negative 9.81. We have to actually compute what the acceleration is, and we have a few equations from the one-dimensional chapter that we can figure this out. The reason why I'm using one-dimensional chapter is because we're just going in one direction. Okay? There's a few equations you could use. This is the equation I would use.
What do they consider a force though? I don't just know.
Yeah, wait.
It's like a way on.
Okay? Then use the easy way.
Wait, do we
We already have an equation.
This is in your note card. This equation's in your note card.
We do have that.
Okay? What do we know? Do we know VI?
No.
Zero.
It's 0.
Zero, yeah.
Oh, so
It starts at rest. We have to change in x. And we know the change in time.
what's that?
Solve for A. I will do it quickly here for you for the sake of time. Your A is 2.67 meters per second squared. That software can't do the easy way, huh?
Why doesn't that work? Well, yeah, why can't you do these?
What is the easy way? I don't even know.
You just square the time and then divide.
No, that's not what I was gonna say. I was gonna say you just use the velocity average as the average size.
Because this isn't an average velocity. You're not getting an average velocity. This is going to be accelerating. It's going to be changing its velocity. You're not going to have an average velocity all the way through that.
Why can't you just square the time?
Why?
Because like, you have meters and seconds, so if you just square the time, you have meters.
That's not how that
seconds.
works. Yeah, that's not how that works.
It's not.
No, no, we can't just do that.
Emma,
Well, multiply that number by 2.
stop.
Oh, because of the 0.5, that's why.
Now listen.
Shh. Yeah, you're doing the same thing, you're squaring.
Wait, why did you
You're squaring the
say
seconds.
25?
Why
Just multiplying by 2. That's
Yeah.
the only thing I don't know why.
What five is one half? It's half.
Okay, so now that we have the acceleration,
Half the It's just part of the equation.
we know the mass.
Oh.
I've learned the easiest lesson. The less I get. The more things that you're on.
Really?
Yeah.
And 13 newtons, and they didn't specifically give us a great direction to use here, but we know that the motion's going to do that, right?
So just downward.
So I would say 13 newtons down the incline.
To the down.
Two down the incline, I'm still not understanding. Like, you are just squaring the seconds.
The downward incline is the
The only
decline?
difference is you have to multiply by 2. Why is it 0.5?
Because that's the equation.
Yeah, that's not.
I'm not sure what you're at.
The answer we got is like half of
So yeah,
what
so
you
you got your meter, which is 0.752.
You have with Isaac.
Square that.
When you and I said your,
No, we still have it.
That's we just split, yeah. The only difference is you multiply by 2. Why you have
Yeah, the off key.
Yeah.
When I go
Oh, it's gonna be the units. Or would that be the
Hey,
units?
That might be an easy answer, it might be a difficult answer. I'm not sure.
Hello. Wait, is Marty here? Oh, now I
What do you need Marty for?
plan on it. Nothing is ever too death.